Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. We're having a look at another one of my ancient sort of electronic archaeology finds of things I made nearly a decade and a half ago and how they kind of work, really. And looking at it, I can see it's kind of a standardized design. I would make these circuits very much in a very standardized way, and I'm probably using Eagle at the moment. Now, interestingly enough, this one has a very close relationship to our current modern day booby board, and the reason is they both use the same microcontroller. This must have been the very first board I used using a PIC 16F688, and as I said in previous videos, I used to get PICs purely based on the fact that I could get free samples and you allowed up to 3 of any each kind and up to I think 5 rows. So I'd always order loads of random PICs that were all similar sort of capabilities because I could program them all up in the same way and use them in my projects while I was working at Loughborough University. And this is the first PIC 16F688 I would have used, and then look how the sort of technology would have changed. So this is a standard DIP package, and then this is a tiny, I think it's QFN they call it. And if you compare them sort of side by side, if the camera can even focus that closely, you can see that the size difference is amazing, right? That's the same chip in essence, but just shrunk down to that little surface mount thing. So you can see there's an evolution here. And actually this let's read the number off, make sure. Yes, it's L7805. Look at this one, that's actually there, an L7805. So this is the genesis, really. This is like the honing of one's craft. So you're doing your sort of home hobbyist. And let's admit, for a home hobbyist, right, you don't expect to see PCBs like this. That is crazy, and we'll go through that in a moment. But yeah, very soon I started just having PCBs made because I was sort of quite confident at this point that I could just do the business. But yeah, I'm going to put this one aside for now. We're going to cover that. That's all of our future videos are based on this now. But it's just nice to show you where it came from and some of the inspiration I had when I was sort of making a new device virtually every day. And I had no bounds with electronics. I just would love to just think of an idea and I would just make it, and I just learn. I completely self-taught myself all these things. So let's look at this circuit, and it looks reasonably well documented at the top. I've obviously marked it out, and I'll just show you the bottom first though, because I'm kind of proud of this. So this would have been, homemade PCB, but just look at that quality of that soldering and the tinning of the board. So this is a milled PCB. So imagine this is all copper when it starts out, and then there's a mill that runs round, and this is a homemade CNC machine would mill this out and go and scratch away the copper, leaving this raw PCB. And then with the little bench drill press, like a Dremel, imagine a Dremel but with a little bench drill press, you put the board in and you basically just go through and go. In fact, I'm getting ahead of myself. This would have been all done on CNC. I'm talking crap. You had a drill file, and then the CNC machine would follow your drill file. When I would hand draw PCBs, that's when I would do the dremeling by hand and drill the holes. Sorry, I got confused. And then after that, you dip the whole board into a solution. I can't remember the name of the chemical, but that would basically silver it, and that's why it's got this lovely, pretty tarnish-free, to be honest, silver matte finish. And it's brilliant for soldering onto, and you can see the quality again of the soldering even on a homemade thing like that is pretty good. It's pretty darn good. So let's have a look, see what this is. And unfortunately the other things had LEDs. This doesn't, because I can tell right away this is a data acquisition board. This is basically for recording data from sensors and into your PC. So it's absolutely marvellous, and I'll show you why. You've got your red, white and black, and that's a curio, isn't it? White. What's the white for? The white is probably, I don't know. I don't rightly know, actually. I thought it would be a programming line, but it is going to this chip. Now, this is a DS275, and I'm going to show you something very much DS275 related right here, because look at these. These are Maxim, who bought Dallas Semiconductors DS275 chips. Exactly the same chips. I've got loads of them. You know why? These chips are bloody expensive. So I used to always keep asking them for free samples. And every time I got one, I put them in here. And now I've got so many of them. I've got too many, if anything, so I'm probably going to start selling these, selling off my old stock. DS275. And what these are level converter chips. The problem is, when you use something like... now I have to think. When you have the RS232 standard... I have a book somewhere. I might need to refer to this, but I'm not going to. I'm just going to try to remember this. And if I've remembered it wrong, please comment down below. But please try to read other people's comments so you don't keep bloody all saying you're wrong. The standard of RS232, I believe, is plus 5 volts to minus 5 volts. Right? The device, which is a PIC, which is your micro, is really only looking for 0 to 5 volts, and in later devices 0 to 3V3 or less, maybe 1.8. yeah. So the problem is, when you hook these together, they don't always work because you're trying to sometimes drive them incorrectly. And again, I'm not quite sure on this minus 5. I might be wrong on that, but basically the DS275 or I think what's the other one? Max 232. Maybe. What these chips do are basically level converters. So they'll convert, I think it might be TTL, or convert this to TTL, true type logic. You don't really need to worry too much about the detail unless you need one. You can dig up the datasheet. But yeah, it's basically though converting the signals between these two. And they were really quite expensive chips. I suspect they still are. So this would be a serial port input. So you have a serial coming in here. So that's connected to your PC. And it's going through the DS275 chip, and then it's going onto this PIC chip, the 688. And the 688, and I'm just going to check an old booby board here, does have a dedicated serial bus. So you've got an RX and TX chip here. So yes, it does. Whereas on a booby board, it doesn't connect out to pins. You can connect to the pins for those, but more, there's an RX and TX pin here, which are dual purpose, because of course you can cut the solder bridges and use this, which is the FTDI 232 chip, which is the USB to serial controller that's on a booby board. So you can take this out of circuit if you want to. With that side, you've got this converting the PC signal to something the PIC can understand, and vice versa. So you can talk to this. On all my devices, normally I had little menus that you could log into and interrogate and talk to these to set them up and save parameters. Very clever stuff. And then here you've of course got your LM78055 5-volt regulator. So this would be 12 volts coming from your car, because this would have been an automotive board, and this would be again going to your power regulator, getting the voltage all down to that, something it's happy with. On the top here you can see this is a pressure sensor. So this would have been trying to measure manifold pressure, doing things with manifold pressure. And then you can see these other things here which say OGS5, OGS4, OGS3, OGS2, OGS1 and RPM, and they seem, look at that bad boy, like buffered auxiliary inputs basically, and they look gorgeous. Look at that. You can see these sort of jumper links here, everything's looking good. So what this board would have done is measure these signals, probably in analog, a lot of them, and then RPM would have probably been in digital, and then convert them to a data stream. So if you can imagine, you've got 1, 2, 3, 4, 5, 6, 7. Maybe this could have been an 8. This really could have been 8. It's not labelled, but it could have been. Let's say 8 pieces of data. So your data stream from your PIC to your PC are basically going to be a stream of numbers. And I can't remember how I would have done it. It might have been, these would have been, could have been hex. So it could just be doing like FF, comma, FA, and they might have been comma separated, or they would have just been a stream. So it'd been like this, load of things, and then maybe just some sort of terminator like an asterisk, so the computer would know, okay, that's my data, and then rely on doing the decoding on the PC end. And what I did is I used a program, I remember at the time I was playing with it, called Dark Basic, and have a look at it if you haven't. It's probably still available. It's really kind of it was okay then. I don't think it was massively popular, but it's like STOS on the Atari ST or Amiga, or Amos on the Amiga. And I used that to draw these dials, graphs, basically digital versions of gauges that look like analog gauges. But what was really cool in my code, I made sure all the needles were damped and everything, so it would be like, nice and smooth, and it was just awesome. I remember that. Gosh, again, that's just like a project sort of came up with and just did it. Made the PCB in a day and the code the next day sort of thing. And that's what that is. So that's an automotive data acquisition module that was just streaming data to a PC. And that's all lovely and homemade. And I think that concludes, though, kind of my little automotive projects right now. The only other one I have, and I need to find the PCB for it, is this. And that is my Land Rover fuel injection system. And it would have had probably the precursor to this board, somewhere between this board's technology and this one went into making this, because this would have had all of the right elements, because this, if you remember, this one's got the MAF sensor, a bit like that, but with the nut on it, and the rev counter, and it would have just been using some of that data to and it would have had a power transistor, probably a tip 121 Darlington pair, firing the fuel injectors with a petrol line just to sort of run the engine on. But yeah, that's bonkers. So that's my sort of little automotive homebrew projects there. Maybe we'll cover some more of these when I find some more digging in my box. But we'll probably just continue on and do a few more little things with booby boards while I've got some. I did actually find a bunch of lost code, so that inspires me to recreate what I was trying to do with those projects all those years ago. But let's have a go making them. If you want any bits and bobs, by the way, start looking at www.backofficeshow.com or just backofficeshow.com. Don't need the www anymore. And you'll be able to sort of see some bits and bobs, because I'm going to start putting some of these on the web so you can buy them, especially things like booby boards and probably some baby boomers. We'll go through some of the baby boomer amps if you want some audio projects, but I'm going to start putting more and more stuff on there. I want to share the projects, and we'll all make these together. As ever, guys, keep safe. Like, share, subscribe if you're that way inclined. Have a look. Feast for the eyes. As ever. Thanks for watching.